Everyone can see this?
Yeah.
Cool.
Right, so it's 6 p.m., so 6 p.m. in Copenhagen, so we should get started. So welcome to the second VMACS Junior Seminar. So this time we have Victoria Gregory presenting her paper, Firms as Learning Environments, Implications for Earnings Dynamics and Job Search. So before we start, a quick reminder of the ground rules. So everybody's audio and video is muted. You cannot change this, and we will not unmute you without prior consent. You can ask questions during the talk via the Q&A function at the bottom of your screen. And so please do not use the chat, but the Q&A if you have a question. So you know that there are no co-authors on this paper. So what we're going to do is the following. So Victoria will answer clarifying questions during her talk. And if you have a clarifying question in the Q&A, just write clarifying in front so that we know it's a question that we'll interrupt her with. And then she'll answer more substantive questions after the talk. So there will be the usual 15 minutes for discussions after the talk. And you can also have the option, as usual, that you can just raise your hand if you want to say something using the participant box at the bottom of your screen. And we will then select you to directly ask the question to the speaker. So now I look forward to the presentation. And Victoria, the floor is yours.
All right, thank you guys. Thanks for tuning in, and thanks to the organizers for having me on. So I'm going to present my job market paper. And in this project, I'm going to think about the role of firms in the formation of human capital and how this impacts earnings outcomes over the life cycle. So my main motivating question is why the cross-sectional variance of earnings increases with age. So this means that there's more inequality among older workers compared with younger workers. And I think exploring the life cycle patterns of inequality is important because it helps us understand the components of inequality that arise as workers progress through their careers. And so people have obviously thought about the sources of earnings inequality before. And so one view is that it comes from inherent differences across workers. And these could be things like variations in skill or human capital, and they could be present at labor market entry or further develop over time. It could also mean that people earn different amounts in levels, or people have inherently different growth rates of income. And then a second potential possible source of earnings inequality is frictional wage dispersion. So similar workers looking for jobs differ in the types of firms that they meet, and this affects whether they're able to match to high-paying firms or how much their earnings grow on the job. And so understanding the extent to which earnings outcomes come from differences in skill or from frictions is important for determining how much redistribution is desirable or feasible. So in this paper, I'm going to investigate a mechanism that interacts differences in skill and search frictions to help explain the increase in life cycle earnings variance. So I'm going to show that firms matter for a worker's earnings growth, which means that the firm that you happen to match with substantially impacts your trajectory of earnings throughout the match, even after controlling for worker differences. And then motivated by this fact, I'm going to link these differences in firm earnings profiles to the human capital growth of workers. More specifically, I'm going to be thinking about human capital as the kind that's accumulated on the job and further develops after workers enter the labor market. And what's going to happen is that workers are going to spend different amounts of their lives in high growth firms, which means they're going to accumulate different amounts of human capital, which translates into earnings variations. And so in this way, employer differences and labor market histories together affect the skills of workers. So what I'm going to do in this paper is build a model that will let me differentiate between some different sources of earnings growth. It's going to be a life cycle search model with on-the-job search, two-sided heterogeneity, and a few new ingredients. I'm going to discipline it with administrative matched employer-employee data. And then combining the model together with the data, I'll be able to disentangle a few different sources of growth. And then this is also going to be able to help me to decompose the life cycle earnings variance profile and understand the contribution of firms to this variance. So an important part of the paper is going to be understanding why people's income grows at different rates, because this is one of the forces that generates differences across workers that increase over the life cycle. And so I'm going to have three main channels that are each tied in different ways to either worker or firm characteristics, and that stem from either human capital or search frictions. And so the first and novel channel of this paper is the idea that firms promote human capital among their employees differently. And I'll be calling these differences in firm learning environment. The idea is that some firms offer faster speeds of on-the-job learning, which increases productivity and therefore wages both in the current job and in subsequent jobs. And I'll be thinking of these intrinsic firm differences as coming from things like differences in technology, managerial quality, training protocols, something like that. And then the next is an intrinsic worker difference in human capital accumulation. So some workers experience faster earnings growth than others, regardless of which job they're at. And so either way, if you have an increase in earnings coming from human capital, you can kind of think of this as promotions you get as you pick up in your job, as you pick up and improve new skills. And then finally, firms will also impact a worker's earnings growth through labor market competition. And this is just the idea that more productive firms are able to raise wages more to keep workers from moving to competitors. And this is like you getting a standard yearly raise at your job. So the main findings, one main finding is going to be that dispersion in human capital is the main driver of the rise in life cycle earnings variance. And this is going to be because workers accumulate human capital at different rates, depending on which firms they match with, as well as their own ability. And then I want to understand what's the contribution of this new firm learning environment channel. So I find that if human capital differences only arose due to differences in who you match with, we would be left with around 41% of the rise in earnings variance as observed in the data. And so this comes from a version of the model in which all workers start off identical. So the only things that differ ex ante are the firms. And this exercise really highlights how much labor market histories impact human capital accumulation opportunities. And it's where the interaction between worker differences and search frictions will really come in. So here, the search frictions are not only going to shape the skills of workers, but also impact how rents are split. And then I'll also find that the role of firms is highest early on in the life cycle, and their importance diminishes as workers find time to get better matches and catch up with their peers who may have been a lot luckier early on. And so other work has attributed the rise in life cycle earnings variance to like worker learning ability and or persistent shocks to human capital. So I'm kind of opening the black box on this front because in my model, the shocks are persistent because they represent labor market transitions. And then I also consider how attributes on the firm side affect earnings growth as well. So firms impact human capital, so what? So in the paper, I do 2 additional exercises that demonstrate some broader implications of this fact. I won't have time to discuss both of these in depth, but here's an overview. So in the paper, I show how the results shed light on characteristics of statistical models of labor income that are used throughout macro. And so these models attempt to parsimoniously capture the different kinds of income risks that workers face over the life cycle. And one finding that's emerged from here about workers is that people appear to face permanently different income growth rates. And then these estimated differences in income growth are typically attributed to a worker characteristic. So I estimate these commonly used income processes on my model generated data, and I'll find that even in the version of the model in which there are no inherent differences across workers, I can still recover some degree of profile heterogeneity. So I infer that this is partially shaped by firms. And then my main findings also have implications for policy. So if some earnings outcomes are not due to permanent differences, but rather come about through search and matching frictions, there's a role for policy to impact the allocation of workers to firms. And in the model, the structure of unemployment insurance can be used to affect this. So I show that high unemployment benefits for young workers are optimal because it incentivizes them to find good matches early on. Namely, it incentivizes them to match to a firm with a good learning environment in order to permanently boost their lifetime income. And so unemployment insurance is commonly thought of as like a short-term insurance policy for job loss, but I offer a setting in which it affects more longer-term outcomes like lifetime income inequality. So the outline of my talk is I'm going to discuss the data and show a motivating exercise. Then I'll get to the model, and then I'll discuss how I take the model to the data. Then the first set of results, I'll show some decompositions of the life cycle earnings variance profile. And then I'll discuss the policy experiment. So my data source is an administrative matched employer-employee data set from Germany. And the way it works is all establishments in Germany are required to submit a yearly record to the government for each employee that has worked there at any time in that year. So for a sample from 2002 to 2010, I'll get every employment record for anyone ever employed at this sample of firms. And then beyond that, I get the employment biographies for all of these workers stretching from 1994 to 2014. So this means I can trace them through different firms and through unemployment to the day. And note, so these are actually establishments, not firms. So I may be a little bit sloppy in the language used throughout the data discussions, but these are establishments. And so I observed average daily earnings over the spell, full and part-time status, and then like demographic characteristics like education, occupation, gender, etc. And so what's nice about the data set is that it's administrative data, so very little measurement error. And I get to see the complete workforce of the establishment in certain years. So the main goal of this motivational section is going to be to show that establishments offer systematically different earnings growth rates. So I observe earnings on an annual level, and I'm going to run the following two-way fixed effects models. So I'll regress the log earnings change of person I from year T-1 to T on a worker fixed effect, a firm fixed effect, and a set of year dummies. And then in a bit, I'll add to X an age and a tenure profile. These fixed effects are identified because I observe workers in multiple establishments and different workers in the same establishments. And so here I'm mainly going to emphasize the heterogeneity in the psi, which is the firm effects on income growth. This is kind of a less studied object because people have typically either run this regression in levels in order to understand the contribution of workers and firms to the dispersion of wages, or have just considered the person effects on growth, for example, to show heterogeneity in income profiles. And so remember, this is just going to be estimated on the wage growth of stayers. So I'm not taking into any account between job switches. And then I'm going to be focusing on full-time prime age workers. And then for context, my sample size is here. So this is just a very simple histogram of the establishment's growth effects. And these are just interpreted as the unconditional annual earnings growth offered by each firm in logs. And so next, I really want to have a better idea of how these firm wage premia and growth translate to differences in earnings profiles across firms. So that's what I'm going to be doing on this slide. So here I'm using the estimates of these fixed effects to construct a distribution of establishment earnings profiles while controlling for worker differences in growth. So the idea is to compare the wage trajectories of individual workers who match to different firms along the fixed effects distribution. So I added a common age and tenure profile to the regression, and I did it separately by education group. And so in each chart, the idea is that I'm taking workers with the same education who are hired at the same age, but then I put them in different firms according to different quantiles of this firm fixed effects distribution. And then I trace out their average earnings trajectories that where the only thing that's varying is the firm that they match to. So the outermost lines are the wage trajectories of the 10th and 90th percentile firm, and then the middle is the 25th and 75th, and then the bold line is the medium. So the starting wage is normalized to 0, so it's just showing cumulative log earnings growth since the hiring date conditional on the workers staying. And the main takeaway here is that there's a lot of heterogeneity in how fast workers' wages grow just based off of the firm that they match to. So for instance, a college-educated worker hired at age 25 can expect to see wages grow on the job after 6 years between like 0.1 and 0.4 in logs. So you can think of these firm wage trajectories as sort of piecing together in a worker's individual earnings profile. And so that's why I think they're important. And so next I'm going to use a model to kind of put some structure on where these heterogeneous wage trajectories come from. So now I'll move on to the model. So it's going to be a search model of the labor market with heterogeneous workers and firms. There's going to be on the job search, and the key ingredient is that employers impact the speed of human capital growth and thus wage growth of the workers. So on one side of the labor market, there's workers who face a deterministic life cycle. They work in the labor market from time 1 to capital T, and they accumulate human capital as they gain job experience. Each period, they can be employed or unemployed. and then they all enter the labor market unemployed. And upon labor market entry, they're also going to draw a fixed learning ability A from a distribution G of A. On the search block, so there's search on and off the job. Unemployed workers receive offers with probability lambda U, and employed workers with probability lambda E. And then a job offer is going to be just a draw from some exogenous CDF F of theta. And theta is going to index two firm characteristics, P and Q, which are going to be the firm's productivity and learning environment. So P productivity directly impacts the level of match output. So a worker with human capital H matched with a firm of productivity P will produce PH. And then with probability delta, the existing matches break up, the worker flows to unemployment, and the job disappears. So this search block of the model is where there's like search frictions and uncertainty come in. So you don't know whether you're going to get a job offer or a separation shock. And when you do get a job offer, you don't know which firm you're going to meet. So this is, okay, so for human capital accumulation, this is the law of motion. So what this is saying is that it depends on the worker's age, which this is this D of T function, the worker's learning ability A, and the learning environment of the firm Q. And so it says that the steepness, so it says that the human capital growth is going to be linear in the worker's learning ability in the firm's learning environment. And then the steepness is permanently going to depend on the worker's type A, and temporarily of the learning environment of the firm that they're matched with at the time. So this, I also allowed to depend on age. So this D of T is a human capital absorption function that depends on the worker's age. And so it's going to be declining over the life cycle, and eventually it will hit 0 at some point. And all it means is that the ability to accumulate human capital is going to decline with age, regardless of your learning ability and where you work. And so together, this D of T function, along with the rest of this like human capital accumulation function, is going to give me like an increase in concave shape of human capital for any given worker, which will help me match the average earnings profile. And then when workers are unemployed, human capital stagnates or remains fixed. That's just like a simplifying assumption. So earnings, so unemployed workers receive benefits that are proportional to their human capital, and employed workers' earnings depend on the productivity of the firm, their own human capital, and an endogenously determined piece rate. So growth in human capital is going to directly show up as growth in earnings. And then since match output is P times H, this piece rate W is just going to dictate what share of output is paid to the worker. And so how is this piece rate W determined? So I'll give like a quick overview of this without going into the equations for the sake of time. But if you know Kahoot, Postal, Vinay, and Robin, it's like that, except adopted to my setting with multidimensional firms. So the way it works is that these piece rates W are fixed and can only be rebargained if the worker gets an outside job offer. And so when this happens, the incumbent firm and the poaching firm are going to compete for the worker. There are going to be two cases in which the piece rate will change. So the first is if the poaching firm values the worker more than the incumbent firm, the worker is going to move to the poaching firm and they're going to be under a new piece rate. If the incumbent firm values the worker more, but can also afford to match the maximum that the poacher can offer, the worker is going to stay and use this outside offer to rebargain their piece rate. And then so in either case, the worker is going to end up at the firm which values the worker most, and then the dominated firm will be the worker's updated relevant outside option going forward. So the firm attracts the worker by offering the entire value of the match at the dominated firm, plus a share of the additional rents brought out by the match with this new firm. So these outside options that people accumulate in the search process also matter for earnings growth, in addition to human capital. And then the sigma is the worker's bargaining power. Okay, so getting to value functions. So for the employed worker, they earn P times H times W while unemployed. Then they may get a separation shock in which they go to unemployment. And in that case, their human capital just remains the same. And then learning ability A is always fixed. So then if not, then human capital H is always going to evolve according to the learning environment at the incumbent firm. So that's the firm's current Q. If the worker, so if no outside offer arrives, then the human capital is just going to evolve according to, so the incumbent firm. Then in the case where the worker gets an outside offer, the three cases from the last slide, one of the three cases from the last slide is going to be realized. So either the worker will move and will get a new piece rate, and then the firm that they're at theta prime is updated, or they stay and rebargain the wage, they get a new piece rate at which is WR prime, which depends on the identity of the poaching firm, or in some cases the outside offer is dominated by a previous one, and so nothing happens. For unemployed workers, they earn B times H, and then with probability lambda U, they get a job offer and they decide whether to accept or reject it. And then this WU prime, the starting wage from unemployment, follows a similar rule to the wages in while they're employed, except for the outside option here is just the value of unemployment. So combining the worker and the firm value functions and then applying the wage setting rules, we can get a recursive representation of the joint match value theorem, of the joint match value function. So it only changes if the worker moves to unemployment or to a new job. So there's always, the match always produces PH. If the worker moves to unemployment, their own value is just the value of unemployment and the firm's getting nothing. If the worker moves to a firm with a higher match value in this set gamma m, which represents all the firms that have a joint value greater than theta, so these are all the firms that the worker would rather move to than stay at their original firm, then this just becomes the value associated with moving, which I didn't have in the wage setting slides, but so the new piece rate at this new firm is going to give the worker this value and expectation. And then if the worker stays, nothing changes except for the effect of the additional human capital evolution. And so what's nice here is that the joint value doesn't depend on the wage. This is just because the wage is only representing a transfer of value from the firm to the worker. And so solving this joint match value function is what it's gonna do is gonna order jobs according to the desirability to the worker across these two dimensions of theta, and it determines the equilibrium allocation of workers to firms in the economy and also governs all transitions. And then given this, you can back out what the wages would be. So this sums up the main parts of the model. So I'm gonna recap and talk about some of the mechanisms that are gonna be important for the results, and so starting with how workers can increase their earnings here. So log earnings in the model are going to be the sum of firm productivity, human capital, and the piece rate. So the three ways to increase your earnings would be to move up the job ladder or moving to a more productive firm. That's going to be increasing P. The second would be accumulating more human capital, which happens when workers are young or at good learning environment firms or have high learning ability. And then the third is increasing the piece rate by getting outside offers. So this is also like an indirect effect of tenure, because workers who have been on the job for longer are expected to have more and better outside offers. And that's what I'm going to call accumulation of search capital. And then there are also interesting interactions between the two. For example, workers would be more willing to accept lower starting piece rates to work at a firm with that's more productive or has a better environment for learning. And so some of these interactions will show up later in the results. So then another thing that I want to highlight is how workers trade off these two different firm attributes. And so the different roles of productivity and learning environments combined with the age dynamics of human capital are going to create these trade-offs that vary over a worker's life cycle. So these two charts trace out indifference curves over firm characteristics P and Q. And so the left panel is for a new entrant and the right panel is for a worker with 20 years of labor market experience. So what these are saying is that when workers are young, they highly value the firm's learning environment because their ability to human capital diminishes to accumulate human capital diminishes over the life cycle. So it's important to match to a firm with the high Q earlier on in order to receive permanently higher earnings throughout their lifetime. And then when workers are much older, the learning environment of the firm becomes irrelevant. And so that's what kind of generates these vertical indifference curves on the right panel, because workers are only weighing their job acceptance decisions by the productivity. And so these changes in trade-offs are going to give rise to a lot of the some of the interesting life cycle dynamics in the model. And then, so this chart is a visual illustration of how learning environments contribute to earnings outcomes over the life cycle. So the left panel shows some life cycle earnings realizations for two different agents. So one is in the solid line, and then another agent is in the dashed line. And then each different colored line segment represents a spell in a different firm. And importantly, each of these two workers, so the solid line and the dashed line, have the same learning ability. And so you can see that the corresponding learning environments of each firm in the middle panel and how they affect the human capital accumulation of the workers in the right panel. So you can see that the dashed line worker is consistently happening to meet firms with worse learning environments. And then this causes that worker to accumulate less human capital, which translates to lower lifetime earnings. And so even though they have the same underlying ability, the worker in the solid line ends up with a much higher lifetime income. And so that's kind of the mechanism that I'm interested in, like how these labor market histories affect earnings outcomes over the life cycle. And so this is what I want to quantify in the next section. So I'll get to how I am able to separate all of these different parts of earnings growth out. Yeah, so the big challenge here is that an individual's earnings growth has both worker and firm components. So there are two parts to the firm component. You have the firm's learning environment Q and the firm's productivity. And then these are both determined by the joint distribution F of PQ. And then we have the worker's learning, the worker's learning ability distribution G of A. So what I'm going to do to untangle these is I'm going to use an indirect inference technique to separately identify the parameters of these distributions. So this is just a simulation-based procedure that uses an auxiliary model as the minimization criterion. So, and this auxiliary model can correspond to reduced form moments from the data that the model says are informative about specific parameters. And so viewing the data through the lens of my model helps me figure out which reduced form moments to look at. And then I'm going to match these reduced form moments in the model and the data. So this is going to proceed in 2 steps. So in the first step, I'm going to construct a moment that separates out P and Q at the firm level by comparing the earnings growth patterns of different age workers who work at the same firm. And there's going to be a few sub-steps to that I'll show in the next slide. And then in the second step, I'm going to bring back the two-way fixed effects specification I showed in the motivation to separate worker from firm heterogeneity. Okay, so moving on to part 1. So the first set of moments I'm going to construct is designed to separate the firm specific returns to search capital and the firm specific returns to human capital. So in each sub-step here, the idea will be to isolate growth in one specific component of earnings. So in the data, I observe earnings, and then the model's counterpart is PHW. So in the first sub-step, I'm going to construct returns to search capital by isolating growth in W. So I'm going to use the earnings growth patterns of older workers. So here I'm going to use age 50 plus who are hired out of unemployment. So this older workers assumption is following something used by Heckman and applied by others after him, which is that there should be no human capital at some point because of decline in productivity or proximity to retirement. And then I'm also using this hired out of unemployment assumption to ensure that people have all started from the same outside option. So it gets rid of, so search capital is erased after an unemployment spell. And so this assumption gets rid of different outside options that might be driving wage growth. So now since I'm using stayers, P is fixed because it's people who haven't switched firms. H is fixed by the assumption on human capital. And so any earnings growth for this set of workers should only be coming from search capital or W. So using this group of workers, I'm going to estimate a random coefficients model to obtain establishment by establishment profiles that are informative about the return to search capital. And so this kind of model, basically the main thing is that it allows both the intercept and the slope on the wage profiles to depend on J or the firm. So that's the first part. So then I'm going to use the results from this to obtain a measure of a firm specific return to human capital in the following way. So now that I have an idea of what a firm's growth in W should look like, I want to isolate growth in H. So in this step, I'm going to use earnings growth of new labor market entrants whose human capital should be growing the fastest. And with the data on them, I'm going to pull out the part of earnings growth that should be coming from search capital. So that's what I got from step 1. And then this residual will be informative about the firm's returns to human capital. So then I'm going to construct a similar firm earnings profile by running the same form of regression, but on this residual log earnings growth based on the young workers and new entrants. And then the moments I'm going to target here are going to come from this step. So for each establishment, I'm going to compute predicted earnings growth at experience levels 1 through 10, and then target like various percentiles of this distribution. And I'll show what this looks like on the next slide. And then I'll also use the correlation between 1 and 2 to inform how correlated productivity and learning environment should be at the firm level. So more parameters for this joint distribution. But so I'll get to how this residual earnings growth moment looks here. So this chart shows the model and the data for that moment. And so the outer rings are P10 and P90, and then this is the mean. And so the model can capture these moments pretty well. And what these really show is that there's quite a lot of growth coming from human capital, and that it's quite dispersed over establishments. And this partially drives some of the main results of the paper. It's kind of why I get so much growth from human capital and why there's such a large firm component to this. So this picture in itself tells me that there should be some degree of heterogeneity across firms in terms of how they allow their workers to accumulate human capital. And then so I also want to address the issue that this moment still picks up a worker heterogeneity and growth rates. So I didn't control for that in any way. So if high ability workers tend to match with high learning environment firms, then the moments here are going to pick that up. So to separate these, I'm going to use the 2A fixed effects specification as before. And then I'm going to want to target the relative variances of the worker and the firm fixed effects as well as their covariance. However, there's a well-known bias in these forms of regressions that I want to address. So because these fixed effects are based on workers meeting only a small amount of firms, these fixed effects become noisy measures of the true types, which affects their estimated variances and their covariances. So this problem exists in both the model and the data. And so to put them on equal grounding, I sort of introduced the same degree of bias into the model simulated data. So to do that, what I do is I artificially truncate worker histories in my model simulated data, which would normally be a perfect 40-year panel of workers, so that I get on average the same length worker histories with each worker meeting on average the same number of establishments. And then since I don't have a notion of firms in the model because of one-to-one matching, I'm going to group similar firms based on their quantiles of PQ in the firm distribution. And then, so these moments help me quantify the relative variances of worker learning ability and firm learning environment. So then, so this is just an overview of the parameterization of the human capital, which is kind of the new part here. I make Q&A Pareto distributions. I'm not going to go into this too much, but then the model can match the targets pretty well. So the main thing was that figure I showed you a few slides ago. And then the fact that the variance ratios are kind of close to 1 implies that I have similar amounts of worker and firm heterogeneity, which will be important for generating the results. And then this depreciation function parameters just kind of imply a very gradual decline in human capital growth that is basically 0 past the age of 50 to be consistent with the identifying assumption I used in the first step. And then you can see this very biased correlation estimate in the worker and the firm effects in growth, even though I actually get a relatively low degree of sorting as measured just by correlation in A and Q. And then I'm going to skip the remaining parameters just for the sake of time and then the rest of it is like kind of more standard. So now I'll get into my decomposition of the variance of log earnings over the life cycle. So if you remember, I wanted to think about why earnings inequality increases over the life cycle. And then this model allows me to attribute it to different components and think about what would happen if some dimensions of firm and worker heterogeneity were turned off. So the dashed line is from the data, and then the blue line is from my model. In both cases, the variance rises by around 0.14, and then in general, the pattern's captured pretty well too. So now I can use the model to understand which components of earnings drive the increase. So here I plot the variance of each component of earnings from the model. And so remember that the three components are human capital in red, firm productivity in green, and then the piece rate in yellow. So you can see that the increase in earnings variance is fully driven by the increase in the variance in human capital. And this happens because workers accumulate human capital at different rates, which depend on both their own ability and the types of the firms that they match with. And then it kind of flattens out when they can't learn anymore. And you can see the more standard job ladder effects are on the yellow and the green lines. So you see a slight decline in the variance of productivity as workers settle into a smaller set of more productive firms. And then also a decline in the piece rate as workers find their first jobs and quickly bargain out more of the surplus. So they move workers towards appropriating a greater share of the match output. And so taken together, this human capital channel drives the increase in variance over the life cycle. Without it, you'd miss this. And so you'd have you'd be loading everything onto productivity and the piece rate. So now I want to understand the contribution of firms, and specifically my new the firm learning environment channel, and how that impacts the life cycle rise in inequality. So I ask here, how much would inequality increase if human capital differences were solely driven by temporary firm and worker matches? So I simulate a version of the model in which there are no differences in worker learning ability. So I assign everybody the mean ability from the original learning ability distribution, and then I recompute the life cycle variance profile. And that's what I am showing here in the purple line. So the increase in the purple line is 41% of the increase in the blue line, meaning that firms drive 41% of the increase in life cycle variance. And so which components look different in this scenario? So the main difference here is, unsurprisingly, a lower increase in the variance of human capital, since differences in human capital only come from differences in firms. Another way to interpret these results is that in the full model, the impact of firms is also strongest early on in the life cycle. So despite their own abilities, workers who get lucky early on and match to a firm with a better learning environment get a head start over their peers. And this kind of channel has an important impact early on in the life cycle. And then after this, the contribution of firms declines as workers can catch up better. And so, yeah, I guess the two main takeaways from this exercise are that first, it's not worker-specific attributes that are solely responsible for the increase in earnings variance over the life cycle. So firms also play a role too. And even though these early matches are temporary, they have a persistent effect on the earnings of workers. And then the second is that this setting highlights an environment where search frictions not only matter for how rents are split, but directly shape the skills of workers. So workers differ in the amounts of human capital they accumulate, and part of that is just coming through these labor market histories. Okay, so now I will get into the policy experiment. Yeah, so this broadly comes, this is like, the way this fits into paper is kind of like an application as to why the fact that firms matter for human capital is important. So, okay. So before directly discussing that, I'll just try to discuss the efficiency properties of the model. So there's a wedge between how workers value jobs and how a planner would value jobs. And the reason is that workers don't fully internalize the long-term benefits of human capital accumulation. So they don't receive the entire present value of the match, and some of that goes from the firm. So what happens is that they undervalue the learning environment when making their job acceptance decision. And also firms don't fully internalize their human capital contributions affect future employers of those workers. So what can the social planner do here? So the planner's choice variable is going to be the hierarchy of firms along the job ladder. So in other words, the planner can choose which jobs each employed worker should accept and which jobs each unemployed worker should accept. And in this model, there are going to be some workers who the planner would rather leave unemployed because it's better to leave them available to form other matches later. And so the planner wants the workers to accept less jobs than they would in the decentralized equilibrium. And so the efficient allocation is going to be where all of the bargaining power goes to the worker. And this holds only if the arrival rate of offers is lower than unemployment. So some intuition for this, you need a lower, so for this part, you want a lower arrival rate in employment so that some option value of search is given up when the worker accepts a job. Then otherwise the planner wouldn't care about leaving these workers in unemployment. And then this is confirmed by the empirics because the job-to-job transition rate is lower than the U to E rate. So I might try and skip a little bit of this, but yeah. So the planner cares about joint values and is going to be making the decisions along the same margin of the worker when all of the bargaining power goes to the worker. And then, so caveat here is that this is kind of a partial equilibrium effect. So if vacancy creation was endogenous and if there was a meeting function that depended on the number of unemployed vacancies, the planner would care about the effect of having the planner would care about these congestion externalities. Okay, so what can we do to get worker decisions to be closer to the planner's benchmark? So unemployment insurance in the model sort of raises the reservation productivities and learning environments of workers. So it affects the kinds of job workers accept and can potentially take us closer to the planner's allocation. So I'm going to consider two kinds of changes to the unemployment insurance schedule, which in the baseline model is just B times H. So first I'm going to change this level of B, but keep it constant across ages. And then in the second kind of, I'll also allow for it to vary across age. Then in either case, the new policy change is funded by a lump sum tax on employed agents, such that the net present value of transfers equals the net present value of the tax. And then as I change the policies, we're going to see some trade-offs emerge. So workers are going to become more selective in terms of learning environments, which will raise lifetime income and the output of matches. But workers would also allow themselves to remain unemployed for longer. And so they wouldn't where they don't accumulate human capital. And so there are going to be permanent effects associated with this as well. So it's all about finding which policy can kind of optimally balance out these trade-offs. So first, I'm just going to look at the flat benefit schedule where I don't allow the unemployment insurance to depend on age. So I'm comparing 4 different model outcomes: output, the variance of lifetime earnings, where lifetime earnings is just the entire stream of earnings people get while they're employed throughout their life. The variance of log earnings, which is what I've been looking at before, just the variance of the cross-sectional wage distribution, and then the welfare of new entrants. And so the star represents what I get in the baseline, and then the dashed line is the efficient allocation. And then it's all normalized to 1 at the dashed line. So as you raise the level of benefits, you can kind of see that workers, so what's going to happen is that workers are going to wait to accept higher P or higher Q jobs. And so that'll slightly increase output or better promote human capital accumulation. But as they get too high, the negative impacts kick in. So workers spend too much time unemployed, stagnating their human capital and depressing output. Inequality goes up, or lifetime inequality starts to go up as workers spend too much of their young lives in like suboptimal jobs. And then the ones who get lucky and find good jobs early on spread out the upper tail. And so that's where the lifetime inequality kind of starts to explode. And then if you look at welfare, so the best flat benefit schedule, which is maximized around here, gets welfare about 13% closer to the planner's welfare, just comparing this and this in here. So now I want to ask whether letting the replacement rate depend on age can improve welfare. The intuition here is that you want to target the policy towards the workers whose policy functions are most misaligned with the planners. So these are young workers because of their undervaluation of learning environment here. So I'm searching over policies of the types in the gray lines. So I set the maximum level equal to like the maximum earnings you can get on the at the firm, like outside of the effects of human capital. And then I find kind of like the slope of the replacement rate function that's going to kind of get you, that's going to kind of improve, one that'll improve welfare and one that'll minimize like lifetime inequality. And so all of them are downward sloping. So it says you want to give generous benefits to young workers to allow them to find jobs that will permanently boost lifetime earnings. But then at some point you want them to decrease so that they're incentivized to start to take a job and start accumulating human capital like while they can. And so the one best for lifetime inequality drops off faster to avoid workers having to spend too much time early on unemployed, which would kind of like mitigates the effect of like luck in terms of who meets the high growth firm, who meets high growth firms quickest. So then how do these do in terms of getting us closer to the benchmark? So in general, the best ones don't actually do much to improve output or lifetime inequality relative to the baseline. So you can see that the dashed lines are where the red and the green lines show where these like sloped policies take us in terms of these different outcomes. In terms of welfare, the welfare maximizing one gets you 1/3 of the way to the planner's benchmark from the baseline. And it does mitigate like cross-sectional inequality relative to the baseline. But then in general, the effects are pretty limited over and above like what you get from these like flat benefits. So policies which specifically target learning environment rather than both productivity and learning environment could do better, because as you start raising benefits, workers' reservation policies change in both of these. So it would be better to target specifically learning environments. But in general, they do show how these policies can have impacts on aggregates and like long-term outcomes in the distribution of employment. So it shows how UI can be used for something beyond just like short-term insurance for job loss. So that's basically it. So I've showed that firms play an important role for the formation to human capital. And to get to this point, I kind of delved into the sources of these different firm earnings profiles that different firms offer to their workers. And then I built a model that allowed for several sources of earnings growth and used the data to tell me like which ones are important: human capital versus search, and then worker versus firm. And I found that these heterogeneous firm learning environments, or the impact of the firms on human capital accumulation, is partially responsible for the rise in life cycle learnings inequality. And then I showed how this is important for policies, and in the paper for understanding how these help us learn about properties of like the labor income process. So that's about it. Yeah, so in future work, I'm thinking about like income risk, how the income risk coming through due to different firm growth rates may affect consumption, and the possibility that earnings growth, another way earnings growth could come from firms is through some firms offering better connections to other firms. So another way in which firms may permanently impact the earnings of their workers going forward. So yeah, so that's it.
Great, thank you very much. This was a very interesting presentation, and we already got quite a number of questions here in the chat and also some hands raised. So I'll just start. Maybe I'll just give the word to the people who wrote something in the chat. So let's start with Thomas Drexel. Let me see if I can find you in the list so I can unmute you. Okay, so you should be able to talk now.
Hey, hi everyone.
Hi.
Great presentation, Victoria. So I was just wondering, it's a bit more a suggestion than a question. I was wondering whether you could open up that estimate of psi j that you find in your motivational evidence. If you could, for example, show what firm characteristics are conducive to, say, a high or a low psi j. Because in some sense, you're showing me this psi j matters, and then your model kind of rationalizes why. I just wonder whether with some basic correlations, you can show some direct evidence that supports your story. And the suggestion I gave here in the chat is that you could perhaps rank the average psi j across industries, and then check whether this industry ranking somehow lines up with the ranking that captures something like importance of resources spent on training workers.
Yeah, so I've done something similar to that. So it wasn't with the psi j that I used in the motivation. It was more with the so this procedure here allows me to attribute like a learning environment or like a Q. This is rather like the model's Q to each firm that I am able to estimate this on in the data. So I have done that. So I've looked at how they correlate with industry and size. And so I find a lot of variation within industries. So there's no like clear, obvious pattern, like which industries have or like size categories to that matter, which industries have like systematically the highest learning environments. So I think it's definitely more of like a within industry rather than a between industry story. What I did find, so like on average, I found that sort of like the manufacturing, like construction type industries had like higher, were associated with higher Ys. And I think the way I rationalize that is that these firms are, in these firms, like on the job training is probably really, really important. So I think I think that's exactly what's kind of like that's kind of like the mechanism in this model, and I see it getting picked up in the estimates. So whereas I'm thinking, like I found like healthcare and things like that had lower learning environments, which to me is saying that like perhaps these firms valued the human capital associated with like pre-labor market things like education or something. So I'm thinking that so I'm thinking that it's kind of what it's kind of giving me is that it's telling me like which industries have like the most scope for on-the-job learning, which I think is consistent with the kind of the story in the model. But one thing I'm also working on is that these data also come with like establishment surveys for some firms on the firm side. And so the questions that they ask vary a lot from year to year, but in some cases they ask like they ask things about like what kinds of training do you give to your workers, like how do you foster like coworker teams and things like that. So what I'm working on next is seeing like how well like these measures correlate with some of the responses in the firm survey.
Yeah, that would be cool. Just a quick follow-up. How does it correlate with size? Within industry?
Size, so I think size, there was no clear pattern. So it's in the appendix of the paper, but like in general, within all size classes, within all industry classes, there was a lot of variation within them. And I think together, like the size times industry interaction explained like 36% of the variation in learning environments that I found.
Interesting. Cool.
Yeah.
Thank you.
Yep.
Thanks.
Okay, great. Then we have a question by Adrien Bilal. Do you want to ask the question yourself? I'll give you the permission and if you'd like to ask it, just go ahead.
Thank you. Thanks a lot, Victoria. Super interesting presentation. I really enjoyed it. I had a question regarding the more empirical part.
Yeah.
When you estimate the two-way fixed effect model for the earnings growth, I was wondering whether you were estimating establishment by establishment fixed effects only, or whether the results were also robust to using more random effect estimators to directly estimate the variance, or also fixed effect models, but after clustering establishments in the first step. The reason I'm asking this is that I'm sure you're aware of these recent papers by Bonhomme, Namadon, Mondreza, and then the next one with Holze and Mokstad that show that the kind of the standard fixed effect models tend to overestimate the dispersion and firm effects by 50 to 100%. So it's sometimes twice as big as alternative estimators would suggest. So I was just wondering how robust the results were on that front.
Yeah, so these ones that I did here are using the fixed effects specifications. So I think this chart, so nothing from this part is meant to be taken as like structural. So I try to better take care of those later on in the model, when I take the model to the data. And so what's important here is I think like, I guess, yeah, so I want to understand like how large this like fanning out of earnings profiles is. So this I haven't taken into account, so in this case I haven't really corrected like in a serious way for those kinds of biases. What is important here is that I've kind of like taken out like the major outliers, which seem to really affect the variance. Another exercise I've done is like, so I take the fixed effects distribution, and then I shrink the variance by like 1/4, and then I recompute what these charts look like, and I get something. So it's a little bit less pronounced than it was before, but it's still kind of like the same story going on. So I'm working on doing like a more serious like clustering, like clustering analysis for this like motivational section. I think doing that to kind of doing that in like the estimation and the taking to the model to the data part. So like replacing that step, or like replacing this step with one of the more advanced estimators would kind of be, I think, a little bit computationally hard to like estimate the model like every time and be running those, because I understand they're a little bit like computationally demanding. So that's why I took this alternative approach of like just introducing the bias into the model and the data. But in terms of like random effects, so these ones were run as actually random effects estimators, like the alpha and the J. But these ones don't, yeah, so these ones don't take into account the worker effect, which I think is important, and I think was what you were asking. So I haven't done it that way. But yeah, so okay. Yeah, I've worked on it a little bit for the motivation, and then I think, yeah, so I think the results from directly from this model part, I think, are more like structural and yeah, than compared to what I did in the motivation.
Okay, thanks.
All right, so then we have a question by Stefania Albanese.
Yep.
Okay. Hi, Victoria. Good to see you. Great talk and excellent paper. I have two comments more than questions. So the first one is that my understanding is that you have gender in the data. And if we think about gender wage gaps and earnings gaps over the life cycle, they increase with age quite dramatically. And also there is a difference in lifetime earnings dispersion, conditional education by gender. So this is sort of more of a comment and a suggestion. So there is some evidence that some of the gender wage and earnings gaps are explained by firm characteristics. So women tend to work in smaller firms and so on. But it also struck me that those characteristics, also following up on Thomas's point of what, those psi J's mean, may be related to this earnings environment. So I think your framework could be very useful to try and understand these gender gaps over the life cycle, conditional education, and it has elements that I've not seen anywhere else, in the research on gender wage gaps. So I would encourage you, not in this paper, but in other work to sort of exploit this, because it seems very interesting and promising. The second point is about young workers. So we have a ton of evidence that workers who enter the labor market in a recession do worse throughout their life cycle in terms of their earnings. And so it struck me also that, one thing that could happen in a recession is that, firms, are less able to invest in human capital. So there might be like an effect associated with a recession, that most firms have a worse, learning environment during recession, and that affects workers who enter at a particular point in time. So I'm not sure exactly how long the span of your data is, but so thinking about this sort of cyclical variation in learning environments, given that this seems to be particularly impactful for young people, may give us a way to explain, the evidence that we have on these, very long-lasting effects on earnings for young workers who enter in a recession. And again, it's sort of more of a suggestion. I wouldn't suggest you put it in this paper, but it seems like it would be a way to understand, these important results about low lifetime earnings for young workers who enter in a recession. And if you have already any comments or ideas based on what you've done so far on those points, I'd be happy to hear them as well.
Yeah. So with the gender gap comment, yeah, I think this framework is especially relevant because you said like there is an effect coming from firms, but then especially the human capital effect is also relevant, especially if women are more likely to take time off like mid-career. So I think that's definitely something to look into. And I do have gender in the data. So I can maybe look at like the differential paths that women follow compared to men and the kinds of firms that they meet.
Absolutely. Yeah.
As far as the question about cyclical things, so yeah, this paper was so this paper is definitely the model kind of provides like some mechanism to thinking about like why workers who enter the labor market in recessions, like why their earnings are persistently lower. So like one thing you could think about is they're less likely to find like good jobs earlier on, and so that impacts their ability to climb the job ladder. but there also could be, as you also said, there also could be a human capital effect. Whereas like the firms that exist in recessions have systematically worse learning environments than the ones that exist in like expansions. So yeah, so that's something I've thought about as well. Unfortunately, I'm not able to like estimate like these learning environments with respect to time. I can maybe go back and do it. So actually, this data source actually extended everything back into the 70s. So, and that was maybe like late last year it happened. So I didn't update it for this paper. But with that longer sample span, that's potentially something I could look at. So yeah, that's both really great suggestions. Thanks.
Okay, thank you, Victoria.
Yep.
Okay, so unfortunately time is already up. So we had a couple more questions in the chat, but well, I will send them to you, Victoria, and then you can follow up with the people individually. I think that's the best to do now.
Yeah, for sure. Yeah.
But thank you again for this very interesting presentation and great discussion. And thanks to the audience, and hope to see you again on the next talk on Thursday.
Yeah, thank you guys for having me.
Thanks, Victoria.
Thanks.
Very much. Okay.
Thanks, Victoria.